In our next section, we are going to talk about network layer, and in the first, we'll take a look to layer 3 protocols, then routers, routing process, and basic router configuration. An Internet Protocol address, IP address, is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. An IP address serves two principal functions: host or network interface identification and location addressing. IPv4 defines an IP address as a 32-bit number. However, because of the growth of the internet and the depletion of available IPv4 addresses, a new version, IP version 6, is used, and this guy is using 128 bits for the IP address. And when the PDU named segment reaches the network layer, this layer adds the IPv4 or IP version 6 headers to the segment, and PDU name is converted to packet in our network layer. And let's take a look to the IP version 4 header now. And as you can see that there are lots of fields in IP version 4 header, and they are version field, they are type of service field, header length field, total length field, fragment offset, protocol, TTL, header checksum, source and destination IP addresses, and IP option. Please keep in mind that there are lots of fields in here, as you can see. Let's take a look to the IPv4 limitations. As we talked in our first slide of our course, almost 50 billion devices will be connected to internet by 2020, but however, available IPv4 addresses are decreasing. In spite of IPv4 is still the most common used protocol, it seems like our next step will be IP version 6, which can provide a broad IP address range. IP version 6 provides a huge IP address range and more secure environment. With IPv4, we will not need with IP version 6, we will not need network address translation operation, which converts private IP addresses into public IP address blocks. And let's take a look to the differences between IPv4 and IP version 6. The first difference is address size. IPv4 is a 38-bit number, while IP version 6 is 128-bit number. The second is address format. IPv4 is shown in dotted decimal notation. As you can see, there are dots between the decimal numbers, while IP version 6 is shown in hexadecimal notation. And there's a difference in the prefix notation as well. And the biggest difference between these guys is really the number of the addresses that they are supporting. As you can see that IPv4 is supporting this, and IP version 6 is supporting a really huge number of IP addresses. Let's take a look to IP version 6 header now. IP version 6 header is pretty straightforward. As you can see on the screen, there are 14 fields in the IP version 4 header. As you can see, version, IHL, type of service, total length, and blah blah blah. But there are just 8 fields in IP version 6 header, and they are version, traffic class, flow label, payload length, next header, hop limit, and source and the destination addresses. Let's take a look to the routers now. A router is a Layer 3 network gateway device, meaning that it connects two or more networks and that the router operates at the network layer of the OSI module. The main function of router is IP routing using the routing table entries. If you remember from our previous slides, on the switch there was a MAC address table, and switches were making the switching by using the MAC address entries on the MAC table. But what routers are doing is, this is a router, this guy is keeping a routing table this time, routing table, which consists of IP address entries, and routers are making IP routing by using the IP addresses kept in the routing table. And here is the back plane of a router. As you can see, there are some equipments in here, like on-off switch, like input power connection, like the gigabit Ethernet ports, like USB ports, and something like that. If you want to check routers' physical views deeply, there's a great application on Google Store, Google Play Store, and you can simply go to Google Play Store and type Cisco 3D Interactive Catalog, and you can check the physical views of the routers deeply there. Let's take a look to the router memory now. In router memory, we have four types of memory. The first one is RAM, RAM. The second is ROM, and the other ones are NVRAM and the flash. In the RAM, we are storing the running IOS, which is the operating system of the router, and the running configuration, routing and ARP tables, and packet buffers. In the ROM, we are storing the boot up instructions and a limited IOS. In the NVRAM, we are storing the startup config, and in the flash, we are storing the IOS itself and the other system files. And please keep in mind that just RAM is volatile. So, how a router boots up? Let's take a look to this. The first thing when router is booting up is power on self tests. On this step, the hardware is being checked. Then the ROM loads the bootstrap program and searches for the IOS, which is the operating system of the router. Then IOS is being loaded from the flash, and the startup configuration is loaded from the NVRAM, and in the last step, boot process is completed as everything is loaded into the RAM. Let's take a look to the routing process now. If source and destination have same network IDs, source sends the packet directly to the destination, guys. That's a really important thing that you should keep on your mind. But what is a network ID? Network ID is a portion of the IP address that is used to identify individuals or devices on a network, such as a local area network or the internet. On our later sections, we'll see how we can calculate the network ID value as well. But if source and the destination have different network IDs from each other, source sends the packet to default gateway this time. A default gateway is the node in a computer network using the Internet Protocol suite that serves as the forwarding router to the other networks when no other route specification matches to the destination IP address of a packet. For example, in here, PC1 wants to communicate with the PC4, they have different network IDs. The network ID of PC1 is .1. The network ID of PC4 is .20. I'm going to show you how I calculate these numbers later sections. Then, because of they have different network IDs, if PC1 wants to communicate with the PC4, this guy directly throws the packet to the default gateway, which is the internal interface IP address of this router on the middle. But if PC1 wants to communicate with the PC2, and because of they have the same network IDs, the packet is not forwarded to default gateway, and that is directly forwarded to the PC2. So let's take a look how we can configure an IP address for switch. Now, if you want to communicate the default gateway on a switch, the command we are using is IP default gateway and the IP address of the router's internal interface. And if you want to configure a default gateway for hosts, for example for this PC, if I want to configure the default gateway, on the Ethernet options, there's a field showing us the default gateway. I can simply fill this here with the IP address of the default gateway and configure my host. So, the next thing we're gonna focus on is the routing table. In computer networking, a routing table is a data table stored in a router or a networked computer that lists the best paths to the particular network destinations and, in some cases, distances associated with those routes. The key term in here is the best path. For example, let's say that you want to go from London to Manchester. What you're gonna do is you open the Google Maps perhaps, and London is here and Manchester is in here, let's say. And when you open the Google Maps, you use the London to the from field and you enter the Manchester to the destination field. Then Google Maps shows you a few alternate paths how to get from London to Manchester, but offers you a one best path. That's the faster one. That's the fastest one. So, routing table is something like that too. In the routing table, you will always have the same path, always have the best path for the particular destination. In here, we are seeing an example of the routing table, and we need to type show IP route simply to display the routing table in here. And as you can see in here, for example, that's a routing table entry which shows us the how we can reach the 1.0 network via 1.6. It's saying us, then that's the best path. And in here also we have another best path. We have also routing tables on our PCs too, and to see our PC's routing table, we can type route print on our command windows. So, as I told you, if I want to check the router's routing table, I'm typing show IP route command and I'm seeing the best paths for the particular destinations. So, how I'm gonna examine the routing table entry? So, in a routing table entry, we have some characters, some text characters, and some numbers, as you can see. The first character is you are seeing on the routing table entry identifies how the network was learned by the router. For example, if this route was learned by statically or learned by a dynamic routing protocol such as maybe EIGRP, OSPF, or something like that. The second field identifies the destination to the network. Then this field identifies the administrative distance, which is the trustworthiness of the route source. Then this field identifies the metric to reach to the remote network. And this field identifies the next hop IP address to reach to the remote network. And this field identifies the amount of elapsed time since the network was discovered, and here identifies the outgoing interface on the router to reach the destination network. So let's take a look to router packet forwarding now. Routers automatically know the directly connected networks, guys, and remote networks must be learned by static routing or dynamic routing protocols. For example, if router 1 wants to communicate with the router 2, what I'm gonna do is I'm gonna go to router 0 and say this guy that, hey dude, if you want to communicate with this network, for example, because this guy knows the directly connected interfaces automatically, and this guy does not know anything about in here, and in here also. So what I'm gonna do is I'm gonna go to this guy and I'm gonna configure something saying that, hey router 0, if you want to communicate with the network 2.0, send your packet to, for example, here. Or if you want to communicate with 3.0, send your packet to here. I can manually configure this, or I can use the dynamic routing protocol saying that if you want to go to here, use the EIGRP protocol. If you want to go here, use the OSPF protocol or something like that. I'm gonna show you in much deeper on our later sections again. So let's take a look to the basic router configuration now. In a basic router configuration, we can simply configure a host name, for example. So let's say that we have a router named my router. In the config mode, I need to type host name command, and I need to give a host name to our device. And as soon as I type the enter, as you can see, the host name changed to R0. And if I want to configure the interface, I need to go to the interface mode by typing interface and the name of the interface, which is Fast Ethernet 01 for this one. And I'm typing IP address and the IP address of the interface and the subnet mask of the interface. Alright guys, if you could not understand what I'm telling about in here, don't worry. We are gonna make separate wonderful packet tracer lab examples, and you'll get all of these concepts easily. Trust me. So to verify the interface configuration, the command I'm using this time is show IP interface brief, and I can check the IP addresses attached to each interface for you by using this command.